One more set to go. 4 questions of this free response question. You get 15 minutes to do this. Let's see if I can do it in less than 15 minutes. So we've got a particle that's moving along a curve, so its position blank here, x comma y. They don't actually give us those equations for x and for y, but they give us the derivatives, dy or dx dt and dy dt, and they tell us at time equals 2 our particle is at 1 comma 5. But again, we don't know the actual equations for x and for y, which seems like a bad thing, but that actually does make many things easier, believe it or not. So our first question is the horizontal movement of the particle to the left or to the right? Well, if your horizontal movement is to the left or to the right, that means your derivative of x is either positive or negative at time equals 2. So we're going to plug in t equals 2 into dx dt and see what we get. So you can do that pretty much in your head. If you plug in 2, you'll get 2 plus 2 equals 4. The square root of 4 is 2. So if I do dx, if I really want to show my work here on the exam, I'd put dx dt evaluated at t equals 2 would equal, the square root of 4 was 2 on top over e squared, which of course you don't even necessarily have to evaluate that, but you can. This was a calculator portion, is 0.271, but no matter what, you know it's going to be positive, even without evaluating it. So the horizontal movement is to the right because dx dt is positive, okay? Which means the x will be increasing, therefore it'll be moving to the right. And so I'll just put that in right over here so you can see it. Alright, you definitely want to say something like the horizontal movement is to the right because dx dt is positive, which means x will be increasing or moving to the right. Something like that. As you know, I didn't really use the word it, which is always a good thing. So you'd want to say something kind of like that. Second part of A says find the slope of the path of the particle at time 2. So their slope cues you off. We talked about this a little bit in one of the previous videos. If you want the slope, you actually do want all of dy dx. Now they don't give you that, but you can find it easy enough because in a parametric equation that is dy dt over dx dt, which they give us that in our two functions up here. We have dy and we have dx, so you just divide those two. So to write all out, it would be sine squared of t over square root of t plus 2 over e to the t. Not extremely necessary to write that because we are simply going to take dy dx and evaluate that at t equals 2. So we've already plugged in t equals 2 into dx dt, the bottom one. Was 0.271. And I will remind you again, while I'm only writing 3 decimal places, when I do these calculations, I'm using a lot more than 3 decimal places, so that is not actually the number I'm using in my calculator. If you plug in t equals 2 into sine squared of t, you get approximately 0.827, which, as a reminder, this is the change in y over the change in x, which is essentially slope, which is why I can divide these. And when you divide those, you get 3.055 approximately if you use enough decimal places, which will get you the correct answer on the scoring guide. Alright, so we've got the slope there. Let's keep moving. Letter B. Letter B asks you find the x-coordinate of the particle's position at time t equals 4. Alright, so position. This one's a little harder. We want the x-coordinate, so we don't care about dy dt. We're only going to use dx dt. If we have the derivative, which is velocity, and you want to go to position, we are going to have to take an integral. And so one of the easiest integrals to do is from, we know where the particle is at time equals 2, so we can start at 2 and then we can go to 4 of dx dt x prime, which is the square root of t plus 2 over e to the t dt. Now the reason I went from 2 to 4 instead of 0 to 4 is because I know where the particle is at 2 because they told me where it was. I'll scroll back up here and highlight. At time equals 2, our x-coordinate is at 1. So I only need to know where did the particle move from 2 all the way to 4. And that's what this integral will tell me, how far the particle will go from 2 to 4. But it won't tell me where it is, so I have to add where we started, which was an x-coordinate of 1. And then when I plug it into the calculator, that will tell me where the particle is now at 4. And when you do that, you get 1.253. That's all you would have to show on that one. This is a calculator problem. You would just have to show the integral and get the correct answer. I think that's the 2 points you get. You get +1 and +1 for those two things. Alright, 7 minutes and I'm halfway there. I'm halfway done. It's looking good. Letter C. I think I might come up here for letter C. My computer's getting a little angry here. Letter C. Find the speed of the particle at time t equals 4. Alright, so we're pretty good there. We did this once already. If we want the speed, we got to figure out how fast are we going in one direction, and I don't know if we're going up or down. I'll go up. And how far are we going vertically? And then we can find the third diagonal. And so, well, we know the speed in the x direction is dx dt, and in the y direction it's dy dt. That is a y, even though it doesn't look like one. And we got to plug in t equals 4, which we haven't done yet, so we've got to do it again. And so all you have to do here is when you plug in dx dt, you need to evaluate that at t equals 4. Your calculator can do that for you. You plug it in and you get 0.044. Use more decimal places than that. I think it's 8 after that. And then do the same thing for dy dt. Evaluate it t equals 4. Gets you something like 0.572 or 0.572. And then you do your Pythagorean Theorem, a squared plus b squared equals c squared, and you get the c to equal 0.575 would be your speed of that particle. It also asks for the acceleration of the particle at time t. Oh, I didn't write that down. We'll come back to it. Maybe I can tell you in class tomorrow morning, because it's late and my mind is blanking. It's really easy looking at it, knowing it was easy, but I'm not thinking of it right now. You would take the derivative again, I'm pretty sure. Alright, but let's go to letter D to finish this up. and my computer is not happy. Alright, letter D, find the distance traveled. Oh, if you're looking for distance, you want to know how far. That is simply arc length. Don't know why I want to write it out there, but I do. So, arc length, again the formula, the integral. And we want between second 2 and second 4, so our integral is from 2 to 4 of a nice big square root. And then we're going to take the derivative of x and square it, and add it to the derivative of y and square it, which I'll write them in here, but we do have them. We've been using them all day, which is again why it was nice that they gave us the derivative and not the actual functions. It does make the problem easier. T plus 2 over e to the t. I think I've limit for how long of a video my computer can make. And then sine squared is the other one. And so as long as you plug that into your calculator correctly, you will get 0.651 as your arc length. And I'm sure you would get 1 for this one and 1 point for that one. Alright, I hope that helps clear a few things up and you guys can check your answers before the test. 12 minutes, a couple minutes to